Hello agents, I just received this top secret video surveillance of what might help you in this mission. Please watch the video and see if it can help you solve your mission.
Hi there, this is Jones, and I'd like to help you today with properties of isosceles triangles. Like you can see in the illustration that I've given you an isosceles triangle, and I've given you the names of a few key parts. Of course, the vertex angle is the angle shared by the two congruent legs. And remember, an isosceles triangle is a triangle with at least two congruent sides, so I have to know that a pair of sides is congruent to be an isosceles, and when I do, those sides are called the legs. Right? And where the legs meet to form an angle, that's the vertex angle. Right? So the base is the side that is not necessarily known to be congruent, and the base angles, of course, form the angle between the legs and the base. Right? Well, theorem 4.3, the isosceles triangle theorem, says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So in the diagram or illustration given, AC is congruent to BC, therefore angle A must be congruent to angle B. And the converse of that is also true. If two angles of a triangle are congruent, as in the illustration, angle A is congruent to angle B, then the sides opposite the angles are also congruent, so therefore AC must be congruent to BC. Okay? And lastly, the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So if I have two sides of a triangle congruent as AC and BC are, and I bisect the vertex angle, not only is that bisector perpendicular to the base, but it divides the base into congruent segments. So it's a perpendicular bisector of the base. Okay? Well, those are three very important theorems dealing with isosceles triangles. Let's see if we can prove some things using isosceles triangles. You see in the illustration, I have triangle RTS, and I have some given information. I have the segment WS is congruent to segment WV, so I've shown that by the hash marks there. And the segment WV is parallel to segment RT. And from that, I want to prove that the larger section RT is congruent to TS. Okay, so what I've done is I've given you some statements, and I'm asking you to fill in the reasons so that we can go through the proof. And I'm going to scroll down, and hopefully we can keep, there we go. I've reproduced the diagram for you so that you can have the statements, reasons, and diagram together on the same computer screen. Okay, so once again, I've just rewritten the given information. WS is congruent to WV, so I'll show that in this diagram as well. And WV parallel to RT, so WV parallel to RT, and of course that's given information. And what I'd like you to do then is to go through the rest of the steps. I've written out statements and see if you can supply the reason for each statement. And then when you're ready, or if you're running into trouble and need help, hit continue and I'll be right back. Okay, how'd you do? Let's see. WVS, angle WVS, where's that? That's down here, is congruent to angle S. Okay, well that would be the isosceles triangle theorem that we saw above, right? We're given the two sides are congruent, so if two sides in a triangle are congruent, then sides opposite, or excuse me, angles opposite are congruent. Okay, so we were given that the sides were congruent, we conclude that the angles are congruent. Right? Statement 3, angle WVS is congruent to angle R over there. How do I know that? If you look at the diagram, you'll see that RT is parallel to WV. That's already in the given information. And those angles are corresponding angles. Right? So you remember that if parallel lines, then corresponding angles are congruent. Okay, so since they're parallel lines, the corresponding angles are congruent. Well, now you know that since angle S is congruent to WVS, and WVS is congruent to angle R, that you can conclude angle S is congruent to angle R, and you can use the transitive property, equality, transitive property of congruence. And substitution would also work as a reason for that, because you've taken this given equation, and since WVS is congruent to R, in place of WVS, you simply substitute angle R. Okay? Well, once you know that, you now have the converse of the isosceles triangle theorem, because you have two angles in the large triangle, RTS, congruent, therefore the sides opposite